Okay, now if you graph, we're not going to worry about the $1,000, but we're just going to graph this 1.12 to the t. It turns out, and you could do this in your calculator easily enough, if you do 1.12 to the 6th power, it comes out pretty much close to 2. So if t equals 6, 1.12 is approximately equal to 2. And it's not exactly equal, but there's a number pretty close to 1.12 whose 6th power would be 2. That number being, of course, the 6th root of 2. So if I start with a graph of my basic exponential function, so let's see, here's 1, here's 2, so this would be 1, and then if I double that, I get up here. This would be 2. So this is y equals 2 to the t. The graph of y equals 1.12 to the t can be constructed. The graph of y equals 2 to the t, or approximately constructed, by simply sketching your 2 to the t graph again. But replacing these numbers with six and 12. So that now our graph would represent at least approximately 1.12 to the t. Okay, well that's an idea you want to keep in mind. And we call 6 the doubling time. And that's going to be very significant. I want to come back to compound interest. Compound $1,000 at 12% quarterly. Which would be 4 times a year. means that you add 1/4 of 12%. Four times a year. Okay, so in 2 years, we add 0.12 over 4. Total of 4t times. Each time we multiply by 1.03. So our function is P of t equals $1,000 times 1.03. Now it's not 1.03 to the t. That's what we'd get if we only had 3% annual interest. Remember that we do this 4t times. So we're adding, and let me go back and rewrite something here. Clean that up so it's not smudged as much. So we're adding 1 plus we're multiplying $1,000 by 1 plus 0.12 over 4 because that's how much we're adding. And that's raised to the 4t power because we do that 4t times. And then of course that ends up equaling one plus 0.03 to the 4t. If we compound n times per year, then the same thing, but we're dividing 0.12 by whatever number of times we compound it. And we're doing that n times t times, n times every year for 2 years. And we get $1,000 times 1 plus 0.12 over n to the nt. And I'd better write that a little bigger, because I don't know if I could read it from where you are. okay? $1,000 times 1 plus 0.12 over n to the nt. If we do this with a better interest rate, like 100%, then if we compound n times a year, no, 100% annual interest, 100% is just 1.00. That's just 1 plus 1 over n raised to the nt. Now 1 plus 1 over n to the nt by the rules for exponents is just 1 plus 1 over n to the n raised to the t power. The more you compound, the more you get. So if we compound quarterly, we end up with more money than we do if we compound annually with the same interest rate. If we compound monthly, we end up with even more. If we compound daily, we end up with more than we do when we compound monthly. But the increases kind of level off, okay? Compounding monthly doesn't give you, or daily doesn't give you all that much more than compounding monthly. But still, if somebody gives you the opportunity, yeah, take it. Well, we could compound as many times as we want to. But a lot of times, you can invest money at continuous compounding. That means this number n, the number of times you compound in a year, approaches infinity. Okay, so as n approaches infinity, one plus 1 over n approaches e, which is arguably the most important number in mathematics. Pi is really important, but if you got e, you can get pi. Okay, e's really kind of fundamental in a lot of ways. Okay, so as n goes to infinity, 1 plus 1 over n goes to e. So 1 plus 1 over n to the n raised to the t has to go to e to the t. That's a big deal, and that's why you have an E button on your calculator. Okay, for $100,000 at 100% compounded continuously, P of t equals $1,000 times e to the t. At rate r, we don't have time to make this connection, but it's fairly straightforward algebra that y'all are I think, capable of doing, and we'll see that a little bit later. At rate r, P of t is $1,000 times e to the rt. This is what you get if you replace this 1.00 by r. So instead of 1, you have r, and then you do just a little bit of algebra, and you establish that if 1 plus 1 over n approaches e, 1 plus r over n to the nth power, and I said 1 plus 1 over n approaches e, 1 plus 1 over n to the nth power approaches e. If you put an r in here, then just a little bit of algebra with your exponents gives you e to the rt. Well, that'll come a little later. That's the whole thing there. Okay, well, good. Hopefully we get something out of that and gives you a context